Hi, it's Jan Beta, and I am terribly sorry for not making many videos lately, but if you are living in Europe, you probably noticed that there is a unbelievable heat wave going on at the moment. So it's like 34 degrees Celsius today, and in my little lab here it's even warmer, I guess, because the sun stands right in front of the window, and the window is right here. And this thing here is the only fan I got. Fun fact, I went to the, home improvement store. I wanted to get a big fan for the lab, but they were all out of fans. That's how severe this heat wave is. And we Northern Europeans are not very used to these temperatures, so basically my whole body just works on, it's kind of like a standby mode, so I can't really think straight, and I can't really work really well. And that's the other thing, is that at the moment my work, my day job, is really exhausting, because it's the season where there's the most work to do, and we're only very few people working at the little warehouse I work in, and a lot of people are having a vacation, so there's only a few people doing all the work, and I'm one of them because I had my vacation a couple of weeks ago. So what I'm going to do today is to make a video, having a coffee. I have to clean this mess up that accumulated there over the past days. I did some work in the lab, improving the lab itself. I have a new lighting solution here. I hope that improves my bench lighting here a bit. And yeah, we'll see what I can do with the Commodore 128 today. But at first I have to clean this mess up. And long story short, what I wanted to say is sorry for not making videos. It's incredibly hot, and I'm always coming home pretty exhausted from work, so there wasn't any energy left in me to do this. Yeah. Sorry, hope you understand. So let's clean this up. Okay, that's much better already, I guess. Let's get the Commodore 128 out. Hey there, old friend. So let's do some things. Let's test some things you guys suggested in the comments. Thank you very much for all your suggestions. There were some very good suggestions on what to try next on this board, because I was pretty much out of ideas. If you saw the last video, I'm ending it on a kind of a sad note, and I procrastinated this quite a while because I just didn't know how to go on. And I guess today is going to be checking out the non-socketed chips. I checked all the socketed chips in another board that I brought in, and they seem to work just fine. So I have all your suggestions printed out on paper, or at least some of them. Yeah, there's a lot of stuff I'm going to go through. First thing, that Gadget UK 164, who also has a very nice and much more sophisticated retro hardware repair channel. You should definitely check out if you haven't done so. And he's also a very helpful and very nice bloke. So thanks very much. He suggested I put my scope, which a lot of you suggested I put my scope in DC coupling, to see what the levels are. I made most of the measurements on AC coupling, which means the zero line always stays. You can't really see the level that well because the scale centers at 0. So you have 4 volts, and if you put it in DC, it just goes up from 0 to 4 volts if it's 4 volts DC. So that's a good trick. Yeah. So you also suggested I double check the replaced caps. I did a lot of work on this off camera because I just couldn't. It would have made a very boring video to film me cursing the sport. No, but it's been like it's a bit frustrating, but on the other hand, it's a very I learn a lot about this. So I turned off the fan. Hopefully that stops the annoying background noise. I don't know how long I can take it, so maybe some shots will have the fan noise. So there we go. That's our DC coupling. Yeah, it's our DC coupling. So this is what you guys suggest, basically. By the way, that Commodore 128 repair video, the first part, or the tried repair, was one of the videos I got the most positive feedback on, which is kind of surprising, but on the other hand, I understand, because it was one of the videos I learned the much from, or I had to research the most for to test the things I was testing in the video. And you guys said that it's very helpful to see someone troubleshooting and learning along the way, and very interesting. So that's kind of cool, because I am learning troubleshooting this machine, and you are learning from my troubleshooting this machine, which is kind of the intention of these videos. So right, let's turn the computer on. And what most of you suggested, I think, is that I overlooked a bad data line on pin 34, which is this pin here on the 8502 processor. So I'm going to recheck that data line. And you guys said the levels were too low. So let's see. Turning this thing on. And of course, I haven't even connected the monitor, so it's still a black screen, rest assured. So that's our data line. I'm going to show you what it says on the scope. So, okay, this is pin 34. So that definitely, there seems to be, the level is too low, and there's kind of a floating ground issue there, I guess. Here's another data line. This is how they usually look. So you have very, very close to 5 volts. And the other ones seem to be the same level, and this is 34 again. So 34 definitely is low. So what that means is that there might be an issue with the main processor. There might also be an issue with the Z80, because pin 34 also goes through there, and some logic, and I already traced it a bit, and also goes through this CIA chip on this pin. And it's the same low level signal there. So don't really know how to go about this. It goes through some of this might be faulty, this might be faulty, this might be faulty. This is okay, we checked that. And I also replaced this with another 6526. I have plenty of those because they are also used in the Commodore 64. So we're definitely onto something there. I think I want to check the clocks again, and I really want to check the 2 CPU clocks simultaneously, so I can see if they... I explained in the last video that basically the Z80 clock is like 2 hums, and then it goes low, and 2 humps again, and during the time it is low, the other CPU has its clock signal. So it's like a ballet of chip synchronous chips. Yeah, it was Danielle who suggested that when you change the capacitors, it might influence the frequency of the clocks, which makes sense because the capacitors charge up and discharge. So that's a timing. Some of them are used for timing. I don't know if there's any capacitors used for timing exclusively. Most of them at least, seem to be decoupling caps to smoothen out the voltage. But there might be something here that is timing critical. I'm not sure about that. I'm gonna check the timing anyway. So let's see if the clocks behave. So, probing the clock. The clock, which should be 2 megahertz on the 8502, is on pin 1, and the Z80 clock is on pin 6. So I'm probing pin 6 on the Z80 and pin 1 on the 8502, which should give me the clock signals. So here we are. This is our 8502 clock, and this is the Z80 clock. And as you can see, the 8502, there's a pause, and the Z80 cuts in, and then there's the 8502 and the Z80 for 2 cycles. Pretty neat, isn't it? Well, this seems to work just fine. This seems to be all hunky-dory. So the clocks are alright. Something's pulling pin 34 low. Might be a broken processor. I traced the signal from data pin 34, and yeah, as I said, it goes through here and it goes through here and it also goes through the Z80. So my suspects are these chips here. This one I rule out because there might be something in the socket or something. I'm going to clean that again. This one might be, these ones. So I'm going to desolder these and replace them, I think. Might be worth a try. You should see a chip select pulse on the kernel after reset, because the first thing the processor does is read the ROM after reset. The reset vector, it reads the reset vector from the ROM, so you should see a little chip select pulse on the kernel after reset. So yeah, let's look up which one is the chip select on the kernel. So this is pin 1, this is 28 pins, so this is 28, 27, 26, 25, 24, 23, 22, 21, 20. So this should be pin 20. Let's see what it does on the scope if I reset it. So of course I should turn this on. So now it's on. And there's a little chip select. Reset. Yeah, there's our chip select pulse. So most likely the 8502 is working. Okay, reset, chip select. Let's double check the other pin that is for the chip select, which is pin 22. Just 2 pins there, which is this pin. I suppose there should also be, yeah, there should also be a pulse. So the processor, the 8502, is most likely alright. That's good, isn't it? So Daniel also suggested that I use, he wrote a very long email, thank you for that, sir. And he also sent me a little adapter board he made that I'm going to show in another video when I check out the Commodore 128 in more detail even. So he also suggested to use the 1541 Ultimate as a check. So because it only uses the functioning VIC2 or PLA and a tiny bit of memory to show the picture. For the Commodore 128 it uses a bit more, but if you see the picture you can get some hints to what you have to look for, what is maybe the faulty component. So I have the 1541 Ultimate connected and I'm turning on the computer. And it does its reset routine, which is a good sign, I guess. But the screen remains blank, and if I hit the button, there's a black screen. So I guess it's just a stuck data line there. It might just be the Z80. The Z80 gets incredibly hot. I might just try desoldering the Z80. Okay, desoldering time. Here we are, desoldering stuff. Okay, should be loose. Yep, there we go. Okay, and I'm putting in the socket, I guess. So let's look for a socket. Okay, found some 40-pin sockets. And some CAA chips, and a SID chip. Don't know where this came from actually, but yeah, we're gonna see. Yay! So okay, this socket should now work if we just put in another Z80. So let's see if we can find a Z80. So I just said an idea that's pretty funny for, I guess, some people that are as nerdy as I am. Let me tell you the story. The story goes like this. Bill Hurd, the lead engineer on the Commodore 128 team, claims that for making one prototype they had these things as doorstops at Commodore at the time, because they had this program where they would give you $100 discount on a Commodore computer if you brought in your old computer, no matter what it was. And the ZX Spectrum was, I think it was cheaper than $100 at the time, so everybody bought these brand new, handed them to Commodore, and got a $100 discount on a Commodore computer, which was usually the Commodore 64. And these have a Z80 in there. And what Bill Hurd did, or what he claims he did, was to grab one of these, rip this Z80 out, put it in there, and the prototype worked. So that is what I'm going to do. It's a 16K ZX Spectrum. By the way, this is an issue 2. It should be a bit older than the Commodore 128 in this case. But the processors should be compatible. This is the A version. The B version, I think the major difference is that it's made for high clocks. But the clock in the Commodore 128 is 2 megahertz anyway, so we're just going to put this in here. Let's see what it does. So this would really be pretty awesome if this would fix it, but I'm not very sure about that. So okay, let's turn this on, I guess. Fingers crossed. Maybe that was the whole point. Nope. And we have the same. Okay, so I'm testing the Z80 chip from the Commodore 128 in the ZX Spectrum. This is the CPU from the Commodore 128. Let's see. And sure enough, can't really see it, but so this works. CPU's okay. By the way, what a nice way to plug the ZX Spectrum, which is a pretty awesome little computer. Love these things. So this is okay. So the Z80 definitely works. I think the contacts can also be ruled out. Next thing I'm going to try is to desolder this one and try replacing it with the one from the known working Commodore 128. So I have to desolder 2 40-pin chips. Again, hope to not damage anything. Wish me luck. Desoldering montage. So got a nice socket in, and I have the chip out, of course, obviously. So I'm going to desolder the one from the other Commodore 128 and swap them around, I guess. So let's see how well this went. Never use force on these. If you have to use force, it's too late. So this went very well, I guess. It all looks intact. Whew. Okay, so I am putting in the processor from the broken Commodore 128. So let's see if it works. So if this works, it's not the processor, it's not the CPU. It's none of the CPUs. Yep. And this works. So okay, it might still be one of those logic chips, or what's beginning to be likely is just that there's something shorted or something like that, so the signal's slightly distorted there. It might just be one of those chips as well, because they fail pretty quickly if they get wrong voltages, I guess. So the system still can't start up. It's a bit of detective work, but we'll not giving up yet. Maybe I should look at it with a microscope or something to see if there's something shorted. There are these little traces here. So here's a nice shot of the traces. They are pretty close to each other, and if you are soldering and desoldering, you scratch away the solder mask and maybe make a little solder bridge. Maybe that's what happens, and that's what's pulling this data line on pin 34 of the 8502 down. So maybe that's the thing that happened here. So it's the next day. I had to call it quits for yesterday because I was hungry. I worked on this for a couple of hours again. And yeah, look at this. It totally works again. No, just kidding. This is the board that was working all the time. So the other board is still dead, but I made some more measurements. And this board, I set this board up to compare measurements on the scope, and I found that pin 25 on the 8502 CPU stays low, where normally it goes high after reset. The other stuff seems fine. The reset line itself works as intended. So this is one of the I/O ports, P5 I/O port 5. So I have to research what that is connected to and see if that's gives me some clue about what's wrong. So yeah, this is still quite a head scratcher. Yeah, let's research a bit in the service manual and come back to this. Okay, another idea. I'm just inspecting the board from the back side, from the bottom side, that is. And this is the graphics chip for the 80 color mode, and this is pin 14, and on pin 14 is the data line that is low, that basically goes through the whole system. D4 is on pin 14, and I don't know if you can see it very well, but there's this botch wire going directly over the pin, and it might just be that the pin penetrated through the insulation on the wire, which looks a lot like it. Yep, it was stuck there. So this might just have been the whole problem. Not sure, of course, but it might be. It might have been short and might have pulled the data line a bit low. So let's see, maybe that's the solution. Maybe not, it's just an idea. Okay, testing this. And oh, it totally works again. That was just a short in the cable there. So that little botch wire. Oh man, what a relief. That really feels nice. It was just the little botch wire, so I'm just oh man. Alright, be right back. I'll go somewhere and cry a little. Okay, here's in a nutshell what the fault was and how I found it. You guys pointed me to the data line D4, which is pin 34 on the processor that I scoped, and it was a bit low, bit below the usual TTL levels, which are around 5 volts, usually a bit lower, like 4 and a bit, and yeah. It was low, and I was tracing where the data line went, and I went through the schematics and I measured it, and it was low everywhere, and I suspected that it might have something to do with the processor, and the data lines also go through the Z80 processor, so I desoldered both of the processors and they were both fine. I checked them in other systems, and yeah, I continued tracing where the D4 line goes, and it basically goes all over the system because it's an input and output data line. So I made little signs on the board where it went and measured around and poked, and it was low everywhere. Then I found this spot here on the video chip, the 80-column video chip, where the data line also goes. And guess what? That's where one of the botch wires that were added from factory to the Commodore 128 is going to. And was laying flush on the board, and the little pins penetrated through the insulation, so there was a little short going on there. And that's what caused the whole fault. So everything I did was okay. The capacitor didn't do anything. It wasn't the capacitor causing the fault. It was just me putting this on the bench and this poking through there and causing a short. Yeah. So that's the thing. So I'm going to put some tape there, I guess, or maybe replace the wire altogether. You engineers out there, don't put your botch wires anywhere near through-hole pins. And to every other person troubleshooting these things, it often is the very, very simple stuff. I could have seen this by just visually inspecting the board a bit more thoroughly from the start. I didn't believe this would happen, but yeah, it's always the simple stuff that just happens. So I'm going to put some insulation there, and that's going to be fine. Okay, there we go. Put some Kapton tape on there. I like this tape because it's made for being very resistant to heat, but it also sticks very well to circuit boards, so I use this. So that's it for today. As you can probably tell, I'm really, really, really happy and exhausted, and I'm glad that it only was such a little fault, and I'm glad that I did all the troubleshooting, and I'm very, very grateful for all your great tips that you gave me on Twitter and in the comments. And I'm sorry that I didn't answer all the comments. It was just too much, but I read them all, and I continue to read all your comments, and it's great to have you all sharing your knowledge and giving me hints and tips. And maybe you also learned something from this repair. And yeah, I'm also glad that it wasn't my fault. It was my fault to an extent, but I didn't screw up anything really badly. Thank you very much for watching. The Commodore 128 series is going to continue soon. Probably there's something else coming in between, but I am going to make more videos about the Commodore 128s. If you want to support my work, you can just give this a thumbs up, subscribe to this channel, comment below. You can check out my Patreon. There's a lot of people giving me a small amount of money. There's some behind the scenes stuff on there. that you can exclusively see there. Sometimes videos are on there a bit earlier than they are on the regular YouTube channel, so it might be worth checking out. And you don't have to give much. It means a lot to me. Every dollar you give me means a lot to me and makes things like this possible. I bought this from the money I got from my Patreon, because I don't have an awful lot of money otherwise. So thanks very much. Hope you stay tuned for more. See you all soon. I'm a very happy Jan Beta. Thanks for watching. See you soon. Bye.